Hi everyone, this is page 5 of the Chapter 6 Exam Review for Algebra 1B, looking at quadratics. So the first two questions, I want you to notice, they say tell how many, okay? Tell how many. And you're looking for the roots, which if you recall about a parabola, the roots are the places where the parabola crosses the x-axis. So these would be the roots. Sorry, that's a really messy picture, but these are your roots, okay? And I just want to know how many are there. Your only real options here are 2, 1, or 0. It could be like this and it could cross twice. It could be sitting right up on top of the axis like that and then it would hit only once. Or it could be like floating up here and then it would have none at all, okay? And the way you tell, anytime this is the question, anytime it's how many, you're using the discriminant, which is a piece of the quadratic formula, and it's this. It's the b squared minus 4ac from the quadratic formula. Okay? So really, since this is in standard form for me already, which is actually really nice, I can just jump in and start doing this. So I'm going to do b squared, that'd be negative 30 squared. And please make sure you put that in parentheses. That's a negative number being squared. Has to be in parentheses. Minus 4 times 3 times 75. Okay? So in my calculator, I'm typing in, negative 30 squared minus 4 times 3, oh, you can't see that because of the glare, times 3 times 75, okay, just like that. Enter, and I get 0. Okay. A discriminant of 0, remember the discriminant is the number that when you put it back in the quadratic formula is going to be underneath the square root symbol. And if you take a square root of 0, you only get 0. So that's one solution. Okay? So if your discriminant comes out to be exactly 0, this means you have one real root. And that's all this question was asking. You don't even have to find what the root is. Okay, it's one real root. And as far as how do you know, it's because the discriminant is 0. Okay. I'm out of space. I should write this over here, but I know that because the discriminant is equal to 0. Okay, when the discriminant is equal to 0, I have one real root. Be careful when you're asked that question that you're not too vague, all right? Because I have some people who say things like, well, because it equals 0. What equals 0? Does the equation equal 0? Does some piece of the equation equal 0? Is the root equal to 0? Okay, I don't know what you're talking about when you say it equals 0. So you should use the word discriminant or the abbreviation. That's fine too. So again, number 20, same thing. I'm going to do the discriminant. So I'm going to do 5 squared minus 4 times negative 2 times negative 11. Now this time the parentheses are not important because I have a positive number there. I usually put it in parentheses anyway. I didn't write it that way that time, but the parentheses aren't important because it's not negative. But you will get a wrong answer if you don't put a negative 1 in parentheses. Okay, and this time I got a negative 63 as my discriminant. Well, if I went to take a square root of negative 63, I would get no solution, right? Because I can't take a square root of a negative number. So because this is negative, I have no real roots. And again, for my reasoning, it's because the discriminant is negative. And you can't take a square root of a negative number. Okay, so that's what that one's really asking you to do. Okay, on to some of these questions about properties. Consider the parabola defined by this equation. Identify all of the following characteristics. Okay, first of all, shape of graph. I want to know what is the name of the graph, and I will tell you it's given away for you in the problem. The name of any graph that has an x squared in it is always just going to be a parabola. Okay, almost a dumb question. Okay, but easy points, don't get it wrong. Okay, to find the vertex. This is obviously much easier for this problem because this is in vertex form. So what I would do is look at your equation next to the formula for vertex form. If you want to actually write it out like I am, that's not a bad idea. So that's the form, and here's my equation. Remember, my vertex is h comma k. So if I can pluck h and k out of the problem, I'm good to go. Okay, so my h value is here. Now what I want to be careful of, though, is this is supposed to be a negative sign, okay? And it's not a negative sign down here in my equation. The reason for that is I must have plugged in a negative number, because if you minus a negative, that's when you get a positive. So when you pull the numbers back out of the equation, you have to switch the signs, okay? Because the equation is supposed to have a negative. So this 4 must really be a negative 4 in order to make that be a positive. So it would be negative 4, comma, my k value. Now again, I know that looks like a negative 2, but that minus sign is really part of the equation. It belongs to the equation. It doesn't belong to the number. So my k value is 2, and so my vertex is just negative 4, comma 2. Okay, axis of symmetry. Axis of symmetry, if this is my parabola, let's see, I know it's going to be at negative 4, comma 2. If this is my parabola like this, and I don't know if this is actually what it looks like, my axis of symmetry is this vertical line that runs up and down through the middle of the parabola, okay? And so the equation for something like that, it's a vertical line, and the equation of a vertical line is always x equals a number. Because this goes through the vertex, it must have the same x number as the vertex, which is really your h value. So axis of symmetry is always just x equals whatever h was. If you look back here, it was negative 4, so my axis of symmetry is x equals negative 4. Okay. All 3 of the next questions come from the a value. Okay, when I look at my vertex form, this 3, this is what I'm using to answer those last 3 questions. So opens up or down. That 3 is positive. So I would say A is positive. So that means it opens up. Now, if it opens up, that means it looks like this. And that means the vertex, it has a low point, not a high point. What I'm really asking you here is, does this have a very lowest point? Does it have a bottom, or does it have a top point? This doesn't have a top because it's got arrows that keep it going on forever, but it does have a bottom. So that's a minimum. And that really came from, we knew that because we knew the answer to that last question. We knew that this was up. I wouldn't, again, try to memorize that. I would just think if it opens up, this is what it looks like, and then this point would be a minimum point. And then wide, skinnier, average. That's when you look at the A value. And technically, you're looking at the absolute value of A. That sounds complicated. You're looking at A, but ignoring whether it's positive or negative. The positive or negative is what controls this up here. So I'm just looking at my A value. And if A is bigger than 1, it's growing 3 times as fast, which is going to make it look skinnier. Okay. So really that's because 3 is bigger than 1. Okay, so it's growing 3 times faster than a normal parabola. This is average. Okay, so it's growing 3 times faster upward, which means it looks skinnier than the others. Okay, so let's try that same thing with number 22. I've got this parabola. I'm going to compare it to the y minus k equals a times x minus h squared. Shape of graph, again, please get this right. Parabola. The vertex is your h value and your k value. Now this time my h value is just a 1 because this negative sign belongs to the equation. My k value must be a negative 1 because for this to turn positive it must have been negative when I put it in to begin with. So vertex is at 1, negative 1. That means my axis of symmetry is x equals whatever h was. Okay, so it's x equals 1 for my axis of symmetry. Now here, again, these three all kind of go together. And here your a value is equal to negative 2. Let's just keep that in mind. So because it's negative, that's going to open down. So again, I'm just going to make a note. A is negative. That's how we knew that. If it opens down, it looks like this. And these ones have a very top point. So that's called a maximum. And wide, skinnier, average. Now this is where it gets a little confusing because some people would look at this and say, oh, well, negative 2 is smaller than 1, so it must be wider than average because smaller than 1 is wider. However, the negative sign just controls this up or down thing. So don't think of it as a negative 2, think of it as just a 2. And 2 is bigger than 1, that's going to make it skinnier. It just happens to be upside down. That's what the negative does. So it's skinny and upside down. Okay? So a lot of those you really don't have to do even any math for. It's really more just pulling that information out of the equation. Okay, we've got a few more like this to get through and then we are all set with this chapter.